software again. Okay, then after finish this part, we can move to next part. Pin slope. And again, please use 2 minutes to move the blue ball around and observe the change in the formula, especially the numerator and the denominator. Then move the purple ball around and observe. For example, when I move here, observe the number change in the formula. Okay, 2 minutes. You can play this. Okay, look at here. When I move, okay, here. When I move the blue ball going up, then the numerator in the blue part, that is going up. I move it down. After the horizontal line, I move it down. The value become negative, -6. -6, it means the difference is between those two balls. Okay, I move it to the right. I move it to the left. I move it to the right. I move it to the left. Then we can see the value changes in the denominator here. Okay, then I move it up, move it down, move it up, move it down. That's okay. When I change the ball to the purple one, I move the purple one going up, going down, going up, going down, going up, going down. You can see when I move the ball up, the value here, that is the x location, the y location of it. Here the y-axis, the location is -4, so this part is -4. I move it up to the 5, here is the 5, and the formula here is the +5, a +5, and I move it to the left. I move it to the left to the location x-axis -10. Here is -10. I move it to the right. Here. Okay, sorry. Here to 5, and the value here is 5. I move it to the -5. Here is -5. Okay, can you feel it? Can you feel? Okay, when I move the purple ball going up, going down, going left, going right, and the blue ball going up, going down, going left, going to the right, you can see the change in the formula. This part, I have no idea, but this part in Taiwan, we learned this when we were junior high school students. But some of you, maybe you have different education system, and I think today is a good time to review everything here. Okay, one more minute. If you finish part, we can go to the next. Okay, now let's use this one. I just copy paste the link here. You can use it on your cell phone or on the computer. And the topic of this video game, that's curve fitting. Curve fitting. What is curve fitting? Yeah, before we move to the textbook chapter number 10, I think this video game is really personal. I think it's interesting. Okay, the same. Please use 2 minutes to play this video game. I will not explain anything in 2 minutes. After that, I will say something. Then okay, you will get it, because the history of this this video game is really interesting because it has been founded from the Nobel Prize winner. His name is Dr. Carl Wieman. Okay, I will let you know that. Okay, how to do it? You can pick up balls from the bucket, place 1, pick up 2, pick up 3, pick up 4, then check the curve, check a value. If you cannot find this website, please let me know because this part is really important for you, students in business. But I think the video game here is easy. No pressure, just try. Pick up 2, 3, 4, 5, 6 points. Please, yep, go ahead. Okay, sure. You can search. Google. Please type PHET space curve fitting. Please search PHET curve fitting. Yeah, there are tons of volunteers, and I am one of the volunteer team. We did a translation. I think you can find the language from your country about those themes. Oh, okay. This one is a little bit complicated. You can use this one, curve fitting. It's easier. Okay. 1 minute after that, I will show you how to use this. Okay, let me show you. Okay, let me start from the beginning. Okay, I pick up a ball. I pick up the second one. I pick up, maybe, okay, let me try. Okay, the same. Then I check the curve. I check the residual. Residual is important for us, but now maybe you can ignore it here. I check the value. Okay, now I place the third ball. I just hold the mouse key. I didn't release the mouse key. I hold it, and I am moving around. Not the I mean the ball is moving around, and you can see a black line. A black line is moving to. Okay, I plan to place it here. Okay, get it? Then have a fourth here. Okay, you can follow my way to do this. Similar, you don't need to place the ball on the exact location as I did. No, you don't need that. You can place 4 balls here. Then click linear to click quadratic or cubic. What it will be. Click here, cubic or quadratic. Next time, I will give you some real data from my PhD research. I did a calculation about the bacteria counting and the optical density. I will give you the real data about 20 years ago. About 20 years ago. Okay, click here, quadratic. Wow, it's a curve. And cubic. And cubic. For example, I select cubic, the function. What does it mean, cubic? Cubic is the function x to the cubic root. Sorry, exponent is 3. Exponent is 3, the cubic exponent. And you may suspect how can those the line fits the 4 points so perfectly. Actually, 2 points determine one linear line. 3 points determine a quadratic curve. 4 points determine a cubic curve. If I have the number 5, it's impossible to get it a perfect fitting. For example, I have the number 5 point here. See? See? And the number 6, number 8, number 9. Okay, this part is important to us, especially for students in business. So, okay, one more minute, you can play this part. Then I will tell you how to do the calculation. Remember this part about the chapter number 10, correlation and regression. The operation, excuse me, the operation is very easy. See, I just placed maybe 10 points, then the computer gave us the formula here. Easy and simple. But if you to calculate the step by step, it's not easy for you. Well, maybe next class I will tell you how to calculate. And again, you can reset it. You can have 1 ball, 2 balls, 3 balls, 4 balls, and select curve, select value, and select quadratic. But generally, I believe that in in the field of business, I think the linear regression is the most practical, right? Is it perfect purpose of this one? You can check the chapter number 10. For example, when I buy, there is a famous case. For example, when people spend, for example, I spend $10 for a good, and the meanwhile I may spend $2 for a pack of cigarette or something, and we want to find the relation how much money I spend on the supermarket, and if I spend $20 or $30 or $40, maybe the money I spend on cigarettes or alcohol, wine, spirit, that kind of drink, alcoholic drink, and that is also in proportion to the spend in my money. But you need have a scientific evidence to persuade, to convince your consumer or your boss. Okay, I did an analysis here, and we found the correlation is really good. But you can study the chapter 10 directly. But I believe if you can read my review part of this one, it will be easy for you. And meanwhile, you can observe there are two values here. The lowercase r square. R square is also an important index to express the correlation. The perfect number is 1. It means 100%. Again, R square value, it means the correlation about this one. What is the correlation? I got 1, 2, 3, 4, 5. I got 5 points for 5 data sets. I try to find a curve that can explain this situation, and I select the quadratic the function. What does it mean quadratic? Because that is x squared. Cubic, it means x to the cube. X to the cube. Sure, when the exponent of the x increases, the curve of the fitting becomes perfect. But sometimes it has no meaning. It makes no sense because the dimension is too high. It's too high. Okay? Okay. 2 minutes, then we can switch to next topic. I will organize everything together. Now, maybe it's so boring. When Dada teaches this kind of math, I don't need it. Actually, you need this. You need this. Okay, 1 minute. Then we can move to next. Okay, and please do me a favor. Let me reset it. I pick up 1, 2, 3, 4, and 5 points here. Please pick up 5 balls on the graph. 5, 6, 7, either one is okay. Then check curve. Then check curve. Just select the linear model here. Okay, finish this part. After you finish this part, please move 1 point far away the line and check the R-square value here. R-square value, move 1 point close to the line, or you can move anywhere you want. Hold the mouse key, don't release it. Then please observe the R-square value, what it will be. I move it around. Wow, very close. The R-square, the blue bar is going up. And the chi-square, the S-square, I will tell you what the meaning of this. Sure, if you can put everything in a line, you can see the R-square is 1. The R-square is 1. And I move the third point a little bit down. I move it down, and the R-square value decreased to 0.95. This one is very important for all students in business and biology. I'm background biology, and you are in business. This one is important. Trust me. Please believe me. But this one is easy. The concept is really difficult. The principle is really difficult, but the operation is easy. Again, I move it around. Okay. Oh, very close to 0.99. That's good. That's good fitting. And the chi-square value is close to 0. Very small. Then please do me a favor. Move one up. Move one down. Then click. Check residuals. Click it. Residuals. Again, just a reminder, for most situations, the linear regression is enough for us. But when I was a PG student, we did the regression with log reason, because the growth of bacteria is in exponent part from, for example, 2 becomes 4, 4 becomes 8, 8 becomes 16. It doubles, and doubles. So when I take the regression, I take the log value of the cell number. Then I can get a perfect fitting of there. I will show you next week. But you need to learn about this. Again, if you place 5 points, 5 balls on the graph, click curve, click residual. Okay, what is a residual? I'll explain it later. You can see, uncheck it, check it, uncheck it, check it. Okay, you can see that is a distance vertical distance to the line. This distance is called residuals. Again, what does it mean? Residual is the distance from any one of the data set from the line. This distance is residual. Just a question. I know above the line the residual is positive. Under the line, this part should be negative. How to solve this problem? Easy. As we explained 3 weeks ago, make it a square. Okay, let's check this. Before I leave this part, please check here. When I move it up, you can see the slope of this black line, the fitting line, the slope 0.5. I move it down. The slope is going down. I move it up. I move to the left, to the right. A little bit change on the formula. The equation, you can see y equals 0.34x plus 3.3. Okay, you can use this. Best fit, it means it calculates the best fitting line from the computer. You can check it here. Adjustable fit. For example, here, and here. Okay, you can follow my steps like this. Select adjustable fit. Instead of the best fit that conducted by the computer, you can select adjustable fit and change the x value. It changes the slope of the line. You move the D. The D means the intersection of the line, not the slope. So what is the best fitting? When you move this and you got largest number of R square, then that is the best fitting. You can move it here, a little bit. Okay, 1 minute. Just use this part. Then you can compare to the auto fit, the face fit. Click it. Okay, very close to that one. Okay, 1 minute. We can switch to the next one. Next topic. Okay, I just copy and paste the website here to our group. Okay, the topic here, least squares regression. Least squares regression. Again, the principles and theories in this topic is really not easy. Not easy. But if you use the computer here, we can know, okay, in the future, the computer will help you calculate this part. You just know, you need to know, click here, input your information, you will get a perfect fitting here. And you can do the next step to analyze your information. Okay, again, please go to least square regression, click it. Okay, and here you can select, okay, I should be quiet, I should shut up, and please select any information here you can use. Okay, 2 minutes, then I will be back to explain this part. Because those software, those applications are very well designed, then students can learn many concepts from this. See, orbital speed versus distance from sun. It has a correlation. Yep. Week 17. Week 17. And week 18, you don't need to. Oh, sorry. Sorry. Week 18, you don't need to come to the campus. And I will record how to solve those final questions. I will record the videos on and place the videos on the YouTube. June 12th, I think. Okay. Here. You have something you are not convenient on the day. How about there's one thing, because I asked the TA, she prefers to, because she helps me to correct those exams. But if most students they consider the week 18 is better, I think I can switch to 18, week 18. How do you think about it? Yeah. To week 18. Okay, let me have a vote. Maybe I can wait the Kajabi comes back. Hi everyone, please vote. You prefer to have our final exam on June 12th? Please raise your hand. One vote. Two. And the other choice is the exam will be on June 19th. Summer vacation? Why? Because according to the campus syllabus, summer vacation will be here. So okay, again, you can vote twice. Is either one is okay. If I see you vote twice, that means if both days are okay for you. Okay. Again, let's vote. Which one is the best time for you? Final exam on June 12th. Please raise your hand. 1, 2, 3. Don't worry, you can vote 1, 2, 3, 4, 5, 6. Then okay, you think the week 18 is best for you? 0? 0. Okay. Just on schedule. And Daniel has special events, and we can remind me. I can have an exam for you. Okay. The same rules. You can use any kind of materials during the exam. But I believe that maybe the questions is different from the final exams. Okay. No problem. Okay. Here are some real data from. Is it? Is it? Kajabi, you told me. Yeah, you asked me the purpose to learn this part. Actually, in the past, there are tons of examples. This example is about the height versus shoe size. Okay, and from the x-axis, shoe size in the U.S. The U.S. may be number 5. For example, my feet are not big enough, so I wear the shoes number 7, number 7.5, and my height is inch. Okay, I forgot that here. So it's very significant. The higher the increase in human's height also increase the shoe size. See? It's the correlation, but you don't have any evidence. Now we place every data on this graph and click. Okay. Yeah. See? The red line here, the computer calculates the best fitting. That will be y equals 1.81x plus 50.4. What does it mean? In the future, if I am a shoemaker, I plan to sell the shoes to everyone. And as long as I know the height of the person, I can calculate this one. Then I can estimate how much shoes under certain sizes I can produce. Like this. And here is one. And please. The correlation coefficient, that is R. Here is not R squared. Here is R plus 0.85. And here, here is a different example about spending and salaries. Spending and salaries from the x-axis, average teacher salaries in US dollars. Here, in thousands. And the y-axis is the spending. I think it's very significant. The more money the teacher earns, the more money he or she spends. Okay, get it? Okay, have a 10-minute break. We can come back and we can explain and we can study this part. Okay, see you later.